environment built primarily on the Flash player. So it's a Flash player plus things like local file system access, and because of that, it has sort of an install experience like any other application. It's not something you just download that can access your hard drive. SWIF is basically the Flash file format and a content type that the AIR runtime can handle. SWIC, again, is just basically a Flash or an AIR library format. ActionScript is the language that you author intelligence with in AIR applications or Flash applications, and is very similar to JavaScript, but it has optional strong typing, and it has classes, and it does not have eval, and it is in fact compiled ahead of time to a bytecode. So when you download a SWIFT, you're not getting ActionScript source, you're getting a bytecode. And obviously that allows us to keep the Flash runtime at the 1.5 megs it is today. And a couple of, I'm probably going to mix and match what I refer to the Flash VM as, so it's known interchangeably more or less as AVM2, AVM Plus, or Tamarind Central, depending on what era your brain is in at the moment. And AVM is short for the ActionScript virtual machine, and it's actually an interpreter and a very lightweight, very fast JIT compiler. And ASC is the ActionScript compiler, so that's what takes ActionScript source and will generate this bytecode that can then be embedded in Swift. So, usually I have a slide showing how much C and C++ code there is in open source compared to other languages and so forth, but I don't think I need to explain the motivation of reusing C code to this audience. So there's lots of C code, it does lots of cool stuff. Wouldn't it be cool if you could use it in Flash applications and in AIR applications cross-platform? So a very brief history of the project. There were actually sort of 3 incarnations. I'm going to concentrate mostly on the last one, but just for a little bit of background, I started out with the MSIL writer-based backend for LLVM, and strangely enough, wrote a variant of it that emitted C code, just to sort of prove out the concept, which I could then still just link to, the regular system libraries and so forth. And once I got Doom working with that, I moved on to the second prototype, which was, again, based on the MSIL writer, but generated ActionScript. And that obviously could not link against the standard system library, so I sort of hand wrote very iffy versions of fopen and fclose and various graphic-y things for, again, Doom. And so the current iteration is fairly solid, and it's based on kind of a real code generation engine that was derived from the real Spark backend. So it does all the sort of real optimization passes, all the real instruction selection, all of that. And the C standard library is actually ported today from basically the BSD C standard library. I think I've got another slide on that. The very low-level system services obviously are handwritten in ActionScript. And so the implementation itself is basically just march equals AVM2. And this is kind of the core of the whole technology, and because LLVM is so well designed and architected, it actually wasn't all that much work. It's something like 3,700 lines of C++, some of which still may bear resemblance to the Spark backend, and around 1,000 lines of TD. And the ActionScript virtual machine is actually stack-based. It's fairly similar to Java bytecodes in that way. And that's a little bit in contrast with the way a typical code generation backend works. I mean, you've got your register descriptions and sort of all of that stuff. So I kind of decided to just make up my own machine model, which is sort of loosely based on subset of the x86. So in my environment, there are effectively global variables that are named things like EBP, ESP, EAX, EDX, etc. And then there are also sort of, again, made up registers, 32 general purpose integer registers, 32 general purpose float registers. And I actually do parameter passing more or less in the x86 calling convention on a virtual stack using these virtual registers, which kind of sounds funny, but it actually gives us a little bit of a speed boost over passing parameters the typical ActionScript way, because there's no boxing and unboxing overhead. And there is a concept of sort of RAM, which is just a monolithic chunk of bytes. And in ActionScript, in the Flash player, there's an object called a byte array, which is basically exactly that, only you can usually have lots of them and do various things with them. And accessing that RAM is actually fairly fast with some optimizations that I've added that are actually shipping in Air 1.1 as we speak, and I'll talk a little bit more about the details there. So this is ActionScript you might see as generated from the back end, and kind of doesn't really look like anything familiar. Looks kind of maybe like some sort of very wordy assembly language. Maybe if you're really good at ActionScript, you can see bits of it in there. But my colleague Dick Sweet actually augmented the ActionScript compiler to take what is effectively an ActionScript inline assembler, so you can just sort of throw in there raw AVM2 bytecodes, and that's useful for doing things like arbitrary branching, which ActionScript does not support. It does not have an arbitrary go-to. It also makes various things faster. You can do very fast switch statements, for example, this way, and a couple of other things. So this is kind of the overall build environment. And this is sort of the core here where I've done most of the work is really this back end to LLC. And that, again, generates ActionScript, which you then just pass to the ActionScript compiler with Dick's changes. And you'll generate a SWIF at this point. And what's kind of interesting about the SWIFTs that are generated is that they've got a little bit of extra code that sort of knows about file pointers and standard I/O and so forth. And when run sort of as a quote-unquote shell script, with the shell being this little C shim that I wrote, it actually brings up the SWIF and makes a socket connection to that SWIF and bridges basic file I/O over that to the local system. So effectively what that means is you can take C code, run it through this chunk of tooling, and just execute it on the command line and do sort of basic standard I/O stuff, basic file access. And what this gives you is you can actually totally within this environment do /configure, because I've written several hacky, disgusting Perl scripts to go and run all the llvm stuff, run the ActionScript compilation, and sort of do this wrapping and so forth. So you can actually, with a fair number of packages that you just find in open source, download it, /configure, and make, and it will actually all work, which is kind of convenient, not having to bang out a make file every time you want to build some project you haven't built before. And this was fairly simplistic too. I mean, just a couple thousand lines of Perl and